Okay, it's noon time. Any question this time? Any questions so far? Okay, no question. I'll just go over the overview of the lecture 14, okay? So we get started to talk about the compiler theory in lecture 11, 12, and 13 on lexical analysis and parsers, okay? So basically, here we spend 3 lectures on the theory. So now lecture 14 is using PLY to design the Lexer and the parser. And then lecture 15 is the Taki code. It will introduce the Python virtual machine. So your parser result will be working on the Python virtual machine, and it will be a complete compiler design. So basically here, these few lectures are more about the implementation. Okay, more about the implementation. So today we are on the pre-language, okay? And we are on the pre-system, Python, Lexer, Lex, and Yek, okay? So this one is an example of using the pre to design the calculator language design, okay? So we will go over the overview of the pre Python, Lex, and Yex, okay? And then using the Python Lex, Yex, okay, to design the calculator language. So we'll go over to use the Python pre to design the Lex and Yex, okay? And then talking about the interpreter design for calculator language. Okay, so here, let me do this, okay? Let me actually put this aside. And then let me actually, okay, let me go to my directory. Okay, for the lecture 14, let's actually look at the next, this one is actually next design, okay, lecture 14, and it's using pre language, okay, so let's actually change to this directory. Okay, so I bring up my Visual Studio Code. Okay, so the slice is over here. Let me put the code on the side, okay, so we can switch between slice and code quickly, okay. Okay, first thing is that to use the pre. Okay, first thing is that to use the pre, you need to download it from, install it using pip, okay. So use pip to download it. Okay, sorry, it takes some time. So, and then you basically need to import pre.lex as lex. Okay, so there's a module in pre or lex, and then import it as lex. So there's a lexer, and then you define your tokens, your tokens, okay. And then different token, and it's a regular expression. Okay, so if you are a plus sign, then it will be a plus sign token. Okay, so this one is the rule, regular expression rule for the tokenization stage. Okay, so something like that. And then each function, T number will be the numbers qualification rule, okay? So there is a T value equal integer of T value, okay? This one is the so-called attribute grammar, okay? So you kind of write this down here, okay? So this file is for that. That will come to here later, okay? So first thing is like we actually have this pre and is it actually is a module in Python, okay, but it doesn't create the executable code. No, it doesn't. It is not really a compiler. So basically, this one it is a module. As you can see, we do use the import. Okay, we do use the import. We do use the import and then pre.lex, okay, as lex. We do import it, okay. We do import it. So basically, your program and the lex actually is both in Python domain, okay. So there is no executable you need to generate. It's not like the regular Rex or Python, okay. So at the end, you directly run this program. So the program will be compiled to the Python virtual machine code, okay. There's an intermediate code you will compile to it, okay, and directly run by Python virtual. So in a way, your program and Lex actually is integrated as a Python program. There's no executable code to be generated. So it is actually even easier than the Lexer, yeah, okay. So it actually is easier. And current version of the pre, you need to require Python 3.6 or newer, okay. Don't use older version. Okay, and pre is a pure Python implementation, okay. So there's nothing you need to create the executable code, no machine code, no something. You directly run on it, okay. It's similar to Lex and EX, okay. And then whatever is LR1 passing, okay. Okay, whatever, these are introduction. And then it's done by David, okay. This gentleman is actually a professor in UO Chicago, okay. So also in Illinois. Okay, this is okay. Okay, I will consider to be a parsing framework. You'll find okay, whatever. So basically, it's just like a regular module that you import, just like NumPy or SciPy that you import from it, okay? And then there is a separate two module. One is Lex.py or ex.py. So there is a pre.lex and pre.ex, okay? Two separate module. And then they will check, there is specifically, they will be a pre.lex.py, okay? Provide interface to produce tokens, okay? And ex.py, okay, will actually create an abstraction tree, okay, whatever. Okay, and let me see. Okay, so here, the main difference between ex and ex.py and ex is that ex.py doesn't involve several code generation, so there is no code will be generated. The Python code can be directly run on Python virtual machine, okay? And it will actually build its Lex and parser inside the Python program, okay? inside the Python program. Okay. So unlike Lexer and EX, okay, requires a specialized input file, okay, that is converted to separate source file. Okay, it actually different compiling philosophy. Okay, anyway, let's actually do this. Okay, let's do this. Let's go back to the code. Okay, let's provide a look at the overview of the code. So this one, the tokens is provided by the user. Okay, the user need to write down, okay, what are the token types. Okay, user also need to provide this one. This is similar to the Lex.L file. Okay, the L file you need to generate. Okay, so this you need to write that. And then each pattern you qualify with this one, and then the value, this one also need to be written by the compiler designer. Okay, for each different one. Okay, so there is a T. Okay, T is a token. Token coming in, tokens value will be converted to integer and assigned to the tokens value. Okay, so this one is converting a string. This original string should be a string. TW should be a string, converted to integer and assigned to it. Okay, this is the number. So you may got a number 3, and then convert it to integer 3 and assign to the tokens value. Okay, so each one of it actually take a token, and token has some data field. So tokens value length, okay, plus equal the 9 number. Okay, so this Lexer is the Lexer will be generated. Okay, and /t is t ignore symbol. Okay, whatever. So this one Lexer.lex. So from the Lexer module, the lex function, you create a Lexer based on the grammar rule you given before. Okay, so this one is like when I run the so-called flex, when I run the flex, and then actually say calculator 1.l, okay, and you would automatically generate the so-called lex that whatever lex that one that c, okay, lex that something that c, okay, the c file will be generated. So this one similar to that, you create a Lexer. So this one is your Lexer, okay, is your Lexer. So for here we have a test code, okay. Test code is a string. Triple code will still be a string. So it's a 3 plus 4 times 10 plus minus 20 times 2, okay. So this one is a testing code. So that code is a data string being fit into the Lexer input. So basically this one is like, okay, the upper grammar we given, the token whatever and token rule, would use the Lexer.lex. This one, it would generate a Lexer program. Okay, and your input language called data being fit into here. Okay, and then this one, it will give you the executable result. Okay, it will actually give you the Lexer. Okay, you actually using the data, and then every time you create a token, okay, here, okay, so every time you look at a token, if not token, okay, you finish. Otherwise, you print the token. Okay, so let's do this. Okay, so every data would be fit in to here, right? And then at the end, it will be there's a while loop. Okay, if there's the token doesn't create it, it's none. Okay, if it is none, the program will break. If not none, it will actually print the token. Okay, so basically it's printing token by token by token. Okay, so that's it. So this program we can run it. No such module as print. Okay, I think I changed my. I'm sorry, I changed my version of the Python before, so now it doesn't work. Okay, but it's okay. Let me do this. Okay, so let me show you the installation now. So Python free installation. Okay, so there's a pre, and we need to do pip install pre. Okay, so copy and then paste here and then install. Okay, sorry. I didn't know that I actually. Okay, now it actually installed it. Okay, so server installed it. I didn't know that I used 3.6 before and I changed it to 3.10 for Python. So I haven't checked yet. Okay, it's out. Now it's working. Okay. So every token being generated. So token number 3. Okay. And this 2, I think, is a line number and position number. So it's a line 2, position 1. There's a 3. And then plus sign is line 2, position 3. Okay. So line 1, I think, is here. Okay. It has a change line mark. So line 2, line 3. Okay. So 4 is line 2, position 5. Okay. It's a number. So the tokenizer will provide such an output. Okay. Okay. So this is how this works. So basically, you need to prepare what are the token type you have. Okay. And then each token type, what is the qualifications, regular expression rule, and write the token and so here the token type is the capital names. Okay, and the rule actually is T underline the name. Okay, and then it's the evaluation function that provide a value. Okay, using the T function. Okay, same name as the T number. Okay, I'm sorry, different name. These are simple one. This one actually is a number. So your number is qualified by these. Okay, by this regular expression rule. Okay. Okay. And then after that, build a Lexer and then feed the data into the Lexer. And this build a Lexer, you based on the rule you actually set up to create a Lexer. And this data being feed in here every time you create a token, and then token being generated one by one here. Okay. So this is overall program structure for this one. If you want to try it, okay, you design your own language, you can feed it in that way, okay, to try it, okay. Okay, so that's a Lexer. So Lexer actually is used to tokenize the string. So you have these different tokens, okay. So the input is like this. You convert it to tokens, and token type are here, okay. And then you associate with the ID and the symbol, okay. Okay, this one is just an example here, okay. Token and the symbol. Okay, token type and token, okay. Okay, so here we go through it already, okay. So the Lexer will generate token. So you do for token in Lexer, again, print token, this will work, okay. This will also work. The one we have is a little bit more complicated. We use a Lexer.token and assign it to token. Okay. So we create a token, but you do for token in Lexer, that will also work. You can print. So each token, you can print tokens type, tokens value, tokens line number, and tokens Lexer position. Okay. These are the so-called what? From attribute values. These are different attribute values. Okay. So each token associated with attribute values. Okay, and token, let's talk about token. So token has this different token type, okay. And then plus, minus, time, division, parentheses. These we already have the definition, okay. It's just a single symbol. So there's a R string, okay, R backslash plus. So anyone know about what R really means? Why here the string put the R outside? Anyone know? Hello, anyone know?
I did when I was looking it up, but I can't remember what it was.
Okay, you can put B in front of it. You can put R in front of it. You can put F in front of it. Okay, so when B is actually binary, okay, something like that. R is raw data. So your string, if you have double quote, you say backslash n, then you will be evaluated with as a backslash n. You will be changed that, right? So this is not raw string. This one is that you have backslash plus. You stay as backslash plus. You will not become an escape sequence. Is that okay? That's why you need to put an R there. I mean, regularly your string, if you have a backslash T, you will be tapping, right? If you have a backslash N, you will change your line, right?
Mm-hmm.
But this one, it doesn't allow it. It's a raw string. That's why I emphasize here.
Oh, raw string. Okay, right.
It's raw, it doesn't process the escape sequence. Okay?
Mm.
So a plus sign is a plus sign. Don't change me. Okay? And yet usually this one, because of this, you use it for the regular expression. So here it defines a string for R, especially D for the numbers. Okay? But D plus is one or more digit. Okay? Okay, so number is the only type that need to be using the function to evaluate. Okay, other are just symbols. Okay, this one pretty simple. So number is the only one that need to use this function to check the token. Okay, and then evaluate it. Okay, let's see. These are a little bit more complicated. If some token is 4 symbol, they want it to be this type. Okay. Okay, some token values. They are how to allow the comments in your language. Okay. Okay, and then that's a Lexer design. Okay, Lexer design. And new line mark, if you allow new line mark, okay. Okay, let's see. Here there are more details. You may like to read it more carefully, okay. So then you build a Lexer. You build a Lexer, just call this function, and then they will based on the rule to build your Lexer, okay. And then you need to fit some program there. So the data, okay, data right here actually is from my internal string, but you can open the file and then assign it to a string and fit it in, okay? You can do that. open that and then feed it in, or you may even feed it in by what? By actually line by line. Okay, there are something that you can change. Okay, so here let's set the token, you return the next token. Okay, let's set the input, you actually create a new feed in the input stream. Okay. Here I think okay. Okay, you can turn on the debugger if you want to turn on the debugger. Okay, you turn on the debugger if debug equal true. Okay, these are okay. Okay, we actually go through it already. Object-based design. Okay, yeah, Lexer is an object. Okay, this is an object. This is an object. So. Okay, let me check different directory. Okay, so this one is a simple Lexer. So they are token rule directory. This file you are able to download from my website. Okay, so they are token rule the PLY. Okay. Wait, it doesn't change. So these are the token rule. Okay, we have a separate file, and then this object. Okay, object one. This object one. Let's look at it. You do have a token. You do have the. Okay, instead of that it become a global constant, you can define it in my Lexer. So my Lexer function would have this. Okay. And then you also have a defined rule there. So my Lexer contains different functions, and then you return Lexer.lex. Okay, this is another way to design the Lexer. Okay. And then my Lexer return value assigned to object Lexer. So this one is using the function, my Lexer function, to create a Lexer.lex. Lexer.x, we talk about it, will return a Lexer based on a rule here. Okay, so you write in the top level or write in the functional level is the same. Okay, because we enclose the whole Lexer generation rule into a function. Okay, and then you can return the Lexer to the outside. So here it's possible that you actually use my Lexer to generate a second object. Okay, and then it will be different Lexer. Okay, it will be different Lexer. Other than that, this program is the same as the previous one. Okay. Any question? Okay, so here you have, let's see. Here it is a my Lexer. Okay, you actually can also create it as a class. Okay, this local definition is still local, and you do still have the function. Okay, but you will be a constructor. So when you construct it, you will have this definition and function there. So basically, when you construct it, you use it to create an object. So this is a third way to create a Lexer. Okay, and MW will build it and test on a string. Okay, that is the third way to write it. So there's a way that you actually directly build it on the top level. Okay, there is a directory, you write it on the top level as this calculator ex.py. Okay, this one built on the top level of the module. Okay, and you work. And then you can also try two other ways. Another way is in the token rules. You actually put the rule into a function and use this myLexer as a generation function to generate the Lexer. Okay. Third way is you define myLexer as a class, and then you use the normal way to create object to assign it to a Lexer. A Lexer can build and then test on something. Okay. These are three ways to build a Lexer using pre. Okay. Any questions so far? Okay, no question. We are going to finish this. Let's move on to the parser. Okay. There are tons of the code to talk about the detail. Let's go to the parser. Okay. So how to build parser using pre? Okay, so parser, you also need to write the rules. Okay, it's the Becker's norm, DNF. Okay, you need to EBNF. Okay, Becker's norm form. Okay, you need to actually write. Okay, the rules. Okay, this I think we teach you before. So now the action, okay, the attribute grammar, okay, is over here. Action routine, okay. Left hand side is the grammar, okay. Grammar by the content-free grammar and written in EBNF, okay. And right hand side is your action grammar, okay, and expression zero's value is these two sum, okay. Something like that to describe it in this way. So you need to describe it in that way. Not this. Okay, let's actually look at the code. Okay, let's look at the parser code. So parser is in a separate directory. So this parser code is actually, I tried many different examples before. Okay, so let's look at parser basic. So this is parser basic. Okay, now you import the pre.ex as ex, okay, and you from KLX import tokens. So this KLX is a outside file, okay. So let's look at KLX. So KLX actually is the previous file we have. The number and the calculator things, okay. So this one now become a module. Okay, this one now become a module to the parser. Okay, so parser include, so they are ex and okay, and then each of the rules in the calculator language is written down here. Okay, expression defined as expression plus 10. Okay. So this one is P0, P1, P2, P3. Okay. So P0 equal P1 plus P3. That's a rule. Okay. Any question? Okay. Here show you the evaluation rules. Okay. Pretty simple. Here you actually have a plus sign, whatever. as long as you meet it, okay? And then you create your parser just like your Lexer using this. Okay, so here you actually using, you will actually have calculator, okay, as a prompt, okay, as a prompt. And you read in a symbol, okay, and then if end of file, if you finish and you break, okay. Otherwise, the string, if not string, okay, you will continue. Continue means go back to get a new symbol, okay. Otherwise, you will send the symbol to the sentence or line to the parser and get a result, okay. And let's see, this one I need to use the terminal. Okay, so right here, let's try this one. This one is called, that's called Python. We have parser basic, the PLY. Okay. So basically, we call the Lexer, and Lexer generates such tokens. Okay, so this is the output of the Lexer. When we actually do what? When we do import, we got it. Okay. Okay, right here, let's do 1 plus 2 equals 4 plus 5. I'm sorry, I messed up. Okay, any question? And then end of file controlling you get out. Okay, controlling is the end of file. Any question?
And I forget why when you make a Lex token, you have what it is, and then it's like an address or something. What did, like, number 2317? What are those again?
Number 2317 is like 20 is the value, is the symbol.
Right.
3 is the line 3 and position 17.
Oh yeah, because you're just calling those in the
It's
print.
from the Lexer.
Yeah.
The real parser part is a calculator part. Here are the rules you need to work on. Okay. If you use print, here are the rules you need to work on. How to treat your symbol and a vector, something like that. You need to design your language and make it work this way. Okay. So here, let's see. Okay, I have different ABCD different problems. Okay, but it's okay. Let's talk about it later. So that's a basic parser. Okay, it's a basic parser. So basic parser look like that. Okay, look like that. So you talk about EX. Okay, EX. So EX is the engine behind print. Okay, yet another compiler. Okay, so pre.ex module implement parsing component of the pre. Okay, whatever. So here we do have the call. We go through it already, and this line will be the parser, similar to the dex.dex. Okay, and with the parser can take string in. So parser.parse the string. You can keep doing this. So this one is a configuration for interpreter. Okay. If you have a line, you interpret it. Okay. This is the configuration for interpreter. So calculator will always show up, waiting for your input. Okay. Okay.
Mm.
It's a typical, and they are able to write this regular expression and also the value. Okay, the value is like this. Okay, here are some details. Okay, combine grammar rule functions. Okay, these are okay. Okay, so if you combine these two rules together, you will do this. Okay. Okay, these are two rules, plus and minus. But if you want to combine them into a new expression rule, you can write it this way and then use if LU. Okay. Any question? Okay, this is a combining rule. So each way will work. Okay. And then binary operator, you can combine them. Okay. So this one has an advantage is that you actually can use a binary operator in upper level to write a grammar rule. Maybe easier. Okay. So upper maybe using binary operator instead of using plus. So plus minus can be grouped together. Okay. Okay. And literals you can assign as literal equals these are standard literal. That can be then written in your calculator language. Okay. And empty. Okay, these are some special cases. Okay. Okay, anyway, and then parser will generate such a thing as well. In the middle, because we talk about is actually LALR parser. Okay, so it's also a ship reduce parser. So it show you the step of the ship reduce. Okay. Okay, and here define the precedence of the operators. Okay, who actually have higher priority. Okay, and who has a lower priority. So I believe that here, I'm sorry. Here, I believe that this one would be higher priority. This is lower priority. Okay, so this is higher priority. This is a lower priority. Okay, the lower part has a higher priority. Okay, so assignment. There are some details and if the PLY would generate something like this. Okay, the grammar rules and the terminal numbers. Okay, and okay, something like this. Okay, it will generate a lot of things. Pass that out. Okay, pass that out. Pass that out generate something like this. So reduce using you. It actually give you the parsers intermediate result. Okay. Okay. Other than that, these are very detailed result for the parser. Okay. If you are interested, you can go into that, but that's too much. Okay. So yet provide no special function for constructing abstract syntax tree. However, such construction is easy enough to do on your own. A minimum way to construct a tree is creating and propagating tuple of this in the grammar. So you can build your own abstract syntax tree. Okay. you use your own, you can build your own syntax tree, okay? Using the binary operator. It's binary. I think this one is something like a tree. You have left node and right node, okay? So binary operator. So that become a tree style. And number is like this, okay? So binary operator has left and right node. Okay, and you actually create binary. So this one, you create a binary operator, okay? So you do got left, OP, and the right. Left, OP, and right. So P1, P3, and P2, okay? This is a tree, okay? Okay, so basically you can also build your own tree based on the EX result, okay? That's what you say. So let's go out, okay? So that's not the version we see. That's not a basic one. It had passed out the P1. Okay, let's look at pass out the P1. It's pass tab. Okay. So this one, this one is a table. Okay, table. Okay, so what you have done here using the parser the basic, okay. At the same time, while you run, you will also generate this pasta out. Okay. So this pasta out is an output file when you build a parser. Okay, you will have a product of this. Okay. It's the output while you generate the parser. Okay. So parser is also very simple to be built. Okay, you have to try and you will know. And then you can build multiple Lexers. You can build multiple Lexers. Okay. Okay, so you pass, you can assign Lexer to it to help. Okay. You can assign Lexer to it. So input program would be the text. And you can assign Lexer with the Lexer you have. Okay. Parser you can assign a Lexer to. Other than that, I think there are a lot of details. Okay, so Python in dash double O mode. If you run Python in dash double O mode, okay, it will not work. Let me see. Because Python PLY does not provide the declarator by default, so don't run it in double O mode. Okay, so basically this one is a PLY. You can download it and try out by yourself to design your own language. Okay, and you can build a interpreter pretty simply. Okay. Any questions so far? Any question?
So if we write most of our code and then we can't write like,
downloadable from, I think in its weekly material, you can download it. Okay. Don't worry about the code. The code I think is over here. It's actually in your week 14.
No, when we're working on our term project.
Yeah, you have to design by yourself.
Yeah. So when we're designing our code, but then
You can copy, but you have to modify something.
but then we can't like figure out how to build a parser, or we're running into problems. Can we throw a parser in there or with code that you've already written?
You have to try to debug. Yeah, you try to debug your rule, such as your regular expression or your context-free grammar. If it's wrong, then your parser may not work. So you have to define them carefully. You have to define them carefully. So the demo code here is you can download it. Okay, you can download it from here. Okay, all the code we have for each chapter. Okay, any question? You can try. Okay, you can try. And term project, you can do that demonstration, but we do not need you to be 100% bug free. Okay, it's very hard for you as a first-time programmer for the compiler to be bug free, right? It's actually very hard. So demonstrate a feature that you can demo, making sure that you know what you are doing. That's good enough. Okay. Any question?
No.
No. That's it for today. Okay. Thank you. Bye now.
All right. Thanks.
Bye bye.